Hello, this is Susan Poss. I'm a math instructor at Spartanburg Community College, and we are talking today about solving equations that contain rational expressions or algebraic fractions. I've got a list of steps here for you. I thought you might want to look through these or maybe jot them down. You're going to see me finding the LCD first, so I'll be factoring some denominators in order to do that. And then you're going to see me using brackets to include all of the terms in the equation in a bracket and multiply each term by the LCD. And then I'm going to solve, and sometimes we may have first degree equations and sometimes we have second degree equations. And the last thing I'm going to do is run back to the original equation and make sure I'm not creating a situation where I have a zero in a denominator. If I generate an answer that's going to create a zero in a denominator, I'm going to reject that. All right, so here is our first example. And you will notice down here beneath it, here we are trying to figure out what the LCD is. That's the first step. Trying to factor denominators. The first denominator is prime. Second denominator has a common factor of x. So we're pulling that x out in front and factoring it out, and that leaves an x minus 5 in the parentheses. And then in forming the LCD, we have to list each factor that occurs, the greatest number of times it occurs in any one denominator. So you're seeing an x minus 5, and an x minus 4. And again, this is a product, so these things are multiplied together. All right, so I've copied down the equation and I've copied down the LCD so we can scroll a little bit. And this is where you're going to see me putting things in brackets. And you notice how I'm skipping around and trying to leave some space. So I have room to insert the multiplier, which is this LCD. You're going to keep that over the denominator 1, so here's my LCD. And remember, the reason you want to do this is because you want to clear out the fractions. We want these denominators to go away. Okay, so the stuff in blue is the original equation, factored form in the denominator. The stuff in red is that LCD placed over 1, and now I'm ready to do my cancellation, because again, the reason we did this was to eliminate these denominators. So what I see standing here is an x times x minus 5 times 1. So I'm going to write down x times x minus 5. And what I see standing over here is 3 times x minus 4. And notice that on the bottom all I have is 1 times 1 and 1 times 1 times 1. So I'm not writing down denominators. I've cleared out the fractions. Now I'm going to distribute this x. And since this is a second degree equation, the strategy for solving is to drag everything over onto one side. So I'm subtracting 3x and adding 12 so that I have a 0 on the other side. And finally, I'm going to see if I can factor this trinomial on the left-hand side. And it looks like 6 and 2, both negative, will do the process correctly. Set each of those factors equal to 0 because we've got two factors that are multiplying to produce 0, so one or the other of them must be a 0 multiplier. So I'm generating two results here. X is 2 and x is 6. The last step you want to perform here is to take those answers back to the original equation and I'm inserting a 6 If I put a 6 in here, does that generate a 0 in the denominator? It does not. 6 minus 4 is 2. So let me go over here and try the same thing. If this is a 6 times 6 minus 5, 6 times 1, it does not generate a 0. Looks like this answer is okay. And let me go back and check the 2. If I put a 2 in here for x, does that generate a 0 on the bottom? No, it generates a negative 2. And a 2 over here would give me a negative 3 times 2. Again, it does not create a 0 in the denominator, so both of those are acceptable answers. So again, quickly looking at the steps, factor the denominators, determine the LCD, bracket the equation, multiply through by the LCD, and then solve whatever type of equation you end up with. Oh, and it wanted me to give you the restrictions. Looks like we have 3 restrictions here on this denominator. X cannot be 0 from this first factor. X cannot be 4 from the second factor. And x cannot be 5. If x is 4, we get a 0 here. If x is 5, we get a 0 there. If x is 0, we get a 0 there. So those are the restrictions on that denominator. Okay, one more example, and then I'm going to stop with the solving equations with rational expressions. Again, looking at the denominators, we want to be sure that we have them in factored form. This is prime, this is prime, this is prime, this is already factored. So the LCD needs a factor of x and a factor of x minus 2. And I'm noticing something out here. You could take a little shortcut right here if you wanted to. Those fractions already have common denominator. You could actually combine those and maybe make the work a little bit easier. So I'm going to go in here and bracket everything. I've already done that just to save a little time. And we're going to multiply everything by the LCD. So putting it in here as a multiplier. In order to clear out denominators, be careful, I'm seeing a minus right there. I've got to be real careful about that. Anytime I see a minus, sort of like a little alert goes up. All right, so the x minus 2 cancels out, and here I'm going to get x squared. This whole denominator here cancels out, and I'm going to get plus x minus 6. I don't have to worry about that because it's an addition. There are no sign changes there. Over here, the x minus 2 cancels out. When I multiply these together, I see a 5x squared. And here, the x minus 2 cancels out. And when I multiply those together, be careful, this is a negative, a minus down here. So I see a minus 10x. I'm also noticing restrictions on these denominators. X cannot be 0 here, and x cannot be 2 in either of these other places. So we'll watch out and hope that we don't get a 0 or 2, because if we do, we have to toss it out. Okay, so let me scroll up so you can see a little bit better. This is a second degree equation, so I'm going to drag all of my, I think I'll go to the right. I want a 0 over here on this side, so I'm going to have a 5x squared. This is going to become a minus x squared. I have a minus 10x over there, and this is going to become a minus x. And then when I add 6 to both sides, that's going to become a positive 6. All right, I think I have that right. Whoops, I bumped it. All right, so let's see, how did I factor this one earlier? I think I ended up, I practiced this one earlier, so I didn't have to waste a lot of time playing around with this. This was what worked, I think. Let me look at that and be sure. So on the outside, I see an 8 product. The inside, I see a 3, and I'm going to make them both negative. So here we go. Take the first factor and set it equal to 0. Add 3. divide by 4. Second factor, set it equal to 0, add 2. So I've got two solutions here, and I see a problem. This solution is fine, but I'm noticing over here as I look at my original restrictions, if I go back up here to one of these, let's go back to the original, because it says to go back to the original. If I go back to this original and start to insert a 2 in place of x, you can see that I generate all these zeros in these denominators. So we're going to keep the answer 3/4, and we're going to reject the answer 2.